In this video, I'm going to be talking about the relationship between three important physical properties of gases: pressure, volume, and temperature. And that relationship is seen in the combined gas law. Now, I've written the combined gas law here, but before we start working with it, we're going to go ahead and have to look at these three laws. These three laws, the Boyle's law, Charles' law, and Guy-Lussac's law, is where the combined gas law comes from. So Boyle's law says that at a constant temperature, the pressure and the volume of a gas are inversely related. Mathematically, that's written as pressure of a gas times volume of a gas equals some constant. And on a graph, what that looks like is a curve. And if you think about it, if you increase the pressure of a gas, right, increase the pressure, then the volume is going to decrease. That's why you're having this curve here. And then if you decrease the pressure of a gas, the volume is going to increase. Mathematically, you can think of it, if you have a big number for pressure, then the volume has to be small. If you have a big number for volume, the number for pressure should be small. Okay. Now, Charles' law says that at constant pressure, the volume and the temperature of a gas are directly related. So what that means is as you increase the temperature of a gas, the volume is also going to decrease. The graph is a straight line. Mathematically, the relationship is written as the volume of a gas equals the temperature of the gas times a constant. This temperature is in Kelvin. I think I've reviewed over Kelvin before, but in case you need a reminder, Kelvin temperature is the temperature of the gas in Celsius plus 273. If you forget these in your calculations, you can get every single question wrong. So important, remember that when you're working with gases, we talk about Kelvin temperature, not Celsius temperature. It's very, very important. That's why I have it up here. Okay, final law that all these three laws are going to combine to the combined gas law, but the final law we have to understand is the Guy-Lussac's law, which says that at constant volume, the pressure of a gas and the temperature of the gas are directly related. So if you increase the temperature of a gas, then the pressure is going to also increase. And you can think of this conceptually if you have a container and let's say if you have a pot on the stove, right? And you close it so the volume can't change, right? Because you have it in a rigid container. And you increase the temperature, you just go ahead and put it on the stove, then the pressure is going to increase because all these gas particles are going to get really, really fast, and they're going to keep colliding with the container, increasing the pressure. So that's why Guy-Lussac's law, increase the temperature of a gas, the pressure increases. And again, temperature is in Kelvin. And then when we combine all of these three gas laws together, we get the combined gas law, which says P1V1 over T1 equals P2V2 over T2. And this is a very handy little law that we can use for many calculations. And I'm going to go ahead and show that in the second part of this video.